Now we're going to learn some log rules. This is kind of long, so hang on. Suppose I want to integrate 1 over x dx. Then that's equal to the log of the absolute value of x plus c. Now it's essential that you put in these absolute value signs and the plus c, of course. What if instead of 1 over x dx, I have a differentiable function u? Then the integral of 1 over u du is the log of the absolute value of u plus c. Now let's see how we can apply these. If I take the integral of 2 over x dx, I can write that as twice the integral of dx over x, which is twice the natural log of x plus c. Straightforward. What if I need to change variables? Well, I have x to the first power and x to the 0 power here, so it's a pretty good hint that I can use the log. So what if I let u equal 4x minus 1? Then du is 4 dx. So what if I multiply this by 4 and this by 1/4? This becomes 1/4 the integral of du over u. So that's 1/4 the natural log of u plus c. So it's 1/4 the natural log of the absolute value of 4x minus 1 plus c. Whenever you're going to do this, you do need to check. Can u be negative? If so, you have to have this absolute value sign. Now, you try these. When you're done, restart the video. Sometimes we want to find the area with a log rule. Suppose I have this function y and I want to find the area between the x-axis and x equals 3. Well, if I integrate x over x squared plus 1 dx, then, and I want to start between 0 and 3, because those are my endpoints there. Let's see. The power of the denominator is 1 more than the numerator, so there's a really good chance I can use logs. So let me let u equal x squared plus 1. du is 2x dx. So I'm going to multiply this by 2, this by 1/2 to take care of that. Now, let me change my limits. When x is 0, u is 0 squared plus 1 or 1. When x is 3, u is 3 squared plus 1 or 9/10. So this whole thing becomes 1/2 the integral from 1 to 10 of du divided by u. Nice. So this is 1/2 the natural log. Now this is always positive. So I don't need the absolute value signs of u, evaluated at 1 and 10. So this is 1/2 times the natural log of 10 minus the natural log of 1. Now that's 0. So this is 1/2 the natural log of 10. If you wanted to take this to decimal form, that's perfectly fine. This is about 1.151. Remember, always take it to 3 decimals. All right, you give it a go. Turn the tape back on when you're done. Okay. Now, sometimes you're going to have polynomials like this one right here. Once again, look, this is 1 higher power than this one. So let's see what happens when I let u equal x cubed plus x. du is 3x squared plus 1. Whoa! So this becomes the integral of, I need my dx here, sorry about that, of du divided by u. So this is simply the natural log of the absolute value of u plus c. Now this can be negative, so I do need the absolute values. So this is a natural log of x cubed plus x plus c. Pretty straightforward. Now when you have trig functions, you know tan and secant squared are closely related. If I let u equal tan x, du is, of course, secant squared x dx. So we can have trig functions shoved in here. So this is the integral of du over u, which is a natural log of u plus c. So this becomes the natural log of the absolute value of tan x plus c. Now, here's another situation where I'm not going to get the derivative straight off. If I let u equal x squared plus 2x, now this is 2, and this the highest power is 2, and this highest power is 1. So there's a good chance I can use the log rule. So if I find u prime, that's 2x plus 2 dx. Do you see I've got this factor of 2 here? So if I do this, 2 and a half, this becomes 1/2 times the integral of du over u. So this is 1/2 times the natural log of the absolute value of x squared plus 2x plus c. Now it doesn't do me any good to raise this up to the half power, so I'm just going to leave it. Now, here I've got x squared and x squared. They're the same power, so it's not going to be a straightforward log application. So what do? Breaking down and crying is not an option. If they're the same power, try long division. Try x squared plus 1 into x squared plus x plus 1. Okay, x squared goes into x squared one time. So this is x squared plus 1. Now I'm going to subtract. That goes away, so I'm left with the remainder of x. So this is plus x divided by x squared plus 1. So this whole thing becomes the integral of 1 plus x over x squared plus 1 dx. Now we're getting into a nice form. So this is the integral of dx plus the integral of x over x squared plus 1 dx. Now I can do this one. This is just x. That's easy. Let's look at this one. Now over here, if I let u equal x squared plus 1, du is 2x dx. So if I'm going to not do the multiplying, I'm going to solve this one for x dx is 1/2 du. All right, so now I'm going to replace this. X dx is, let's try du and not dx. Hey, what do you do when you make a mistake? Draw a line through it. X dx is 1/2 du. I get excited and get ahead of myself on these problems. So x dx is 1/2 du divided by u. And there is a plus c out here. X plus 1/2 the natural log of the, now u is always positive, so I don't need the absolute value signs, of u plus c. Now I'm going to plug this in. Log of x squared plus 1 plus c. Okay, now this one, oh my gosh, what do we do on this one? Because that's just the first power and that's the first power, right? So do I do long division? I've tricked you because this really has a higher power of 2. So this is x squared and x. So there's a really good chance we can use the log rule with this. What if I cheat a little bit? And by cheating in math, I mean I'm going to use some sort of trick. What if I let u equal x plus 1? Well then, x is u plus 1. du is just dx. All right, so if I do that, this becomes twice. I'm going to pull that 2 out because it's just in the way. X, okay, when I plug in x, that's u plus 1. All right, now x plus 1, this is u squared, and dx is just du. So this becomes twice the integral. U over u squared is du over u. plus, I need my brackets, the integral of u to the negative 2 du. Oh, well, u can be negative, so I need to make sure I use my absolute values. This is 2 times the natural log of the absolute value of u, plus, now this is u to the negative 2, so it's u to the negative 1, divided by negative 1, plus c. So this is twice the natural log. Let's see, u is x plus 1. And then I'm going to have this minus, let's see. You know what? I can't add, can I? Did anyone else catch that? This is x is negative 1. Happens. So all of these pluses become negatives. What do you do when you make a mistake like that and you don't want to redo everything? You can do that right there. That's fine. So this becomes positive 1 over u, which is x plus 1, plus my constant. All right, you give these a go. Turn the video back on when you're done. We have just a little bit more to do. Suppose I want to solve the differential equation dy dx is 1 over x log x. Now, we can do the solution as an indefinite integral y is 1 over x times log x dx. Now we've got this 1 over situation, so let's look at a couple of options for u. If u is equal to x, then du is equal to dx, but that's not going to help us at all, is it? If I let u equal x log of x, then du, that's by no means what we're going to have, because that's going to be log of x plus 1. That's not what we have either. All right, one more shot to use the log rule, and that's to let u equal the natural log of x, and then du is 1 over x dx. That we have. There's 1 over x dx. So let me rewrite this as the integral of 1 over x dx divided by the natural log of x. Okay, so this is the integral. 1 over x dx is du divided by u. So this is the natural log of the absolute value of u plus c. Now that's kind of funky, isn't it? Because my natural log of a natural log of the absolute value of x. Okay? Kind of wild. All right, here are some general rules for integrating these things. First, know your integration formulas. We've been quizzing you all year. You should have these down. You know the power rule, the log rule, all the trig rules. And yes, we're going to expand it quite a bit. Find a formula that resembles all or part of your integrand, and then try values of u to make it fit, like we did in the last one. If you can't find one that works, try changing the integrand. You may need to use a trig identity. You can have to multiply or divide by 1, something. This is the fun part, okay? This is a puzzle. It is a game, folks. Treat it like a game. You may also want to plug this in your calculator and see what it looks like to give you a hint, but not to solve it. All right, you do this one. See if you can do it. When you're done, stop the tape and finish your homework.